Okay, good morning students. As you know, this is Subodh Pandey and you are floating with me in the world of physics. As you know, we are going through a chapter and your chapter name is surface tension. So continue the journey and we will start your next topic, and your next topic is viscosity, as you can see in your screen. Topic is viscosity. Okay, so what is the viscosity, from where it comes, that things we will discuss in this lecture. Okay, so let's get started. Firstly, as you can see that here there is a term, and the term is nothing but your viscosity. So if we have to go through the viscosity, then it is clear that when a layer of a fluid slips or tends to slip on another layer in contact, the two layers exert tangential force on each other. What does it mean? It means, let's suppose that this is the first layer of the liquid, and below that layer there is another layer of the same fluid, and after that another layer of the same fluid, and likewise there are several layers like this. Okay, so there are several layers, and because the fluid is in motion, so you can easily identify that as we go upward. Okay, so the motion of the layer, or the motion of the particular layer, will be increasing order, will be in increasing order. Okay, so it means if the lower layer has speed v1, then v2, then v3, then v4, v5 and v6 for the upper 6 layers of the fluid, then we can easily see that v1 is very smaller than v6. Okay, it means v6 will be have larger value with compared to v1. Okay, this one thing is very important, you have to remember it. Okay, now as here we can see that the speed decreases continuously as we go downward. Okay, so downward the speed of layers decreases. Okay, so because I have told you that the speed decreases, and what is the property due to which the speed decreases? That is nothing but friction. Okay, because we know that due to the friction between the surfaces, the speed continuously decreases. Okay, so in this way we can simply say that there is a friction between the layers of the fluid. Okay, and that friction is your viscous force, that friction force which is in between the layers of the fluid is the viscous force, and the property is viscosity. I hope and I believe that this is clear. Okay, now what? The direction are such that the relative motion between the layers is opposed. That's why I am saying that the speed continuously decreases as we go deeper inside the fluid which is flowing. Okay, now what? As you can see that the force of viscosity, or we can say the friction force of the fluid between two layers of a fluid is proportional to the velocity gradient. So what is velocity gradient? Firstly, we will draw the two layers for you. Let's suppose this is your first or the upper layer of the fluid, and below it there is another layer of the same fluid, like this way. These two are the layer, and the view is microscopic layer. Okay, it means we have zoomed it thousand times for you, so that you can easily understand. So these two layers, this has the velocity, suppose v, so it has the velocity v plus delta v or dv, whatever you can write, and the perpendicular distance between them is delta x. So velocity gradient, we can simply say that a velocity gradient is nothing but that will be delta v upon delta x, or simply dv upon dx. Means how much deeper we go, and how much the separation between the layers is there. Okay, so dv upon dx is nothing but your velocity gradient. So I hope that this term is clear to all of you. And I have told you here that the viscous force, or we can say the friction force in the liquid flowing, is directly proportional to delta v upon delta x, or we can say velocity gradient. Okay, now what? The force is proportional to area of the layer. So if the area of the layer be capital A, so we can simply write that F proportional to capital A. Okay, so these two results are very significant for you, and when we add these two results, then what we get? We get a common result. As you can see that we have F, and that is proportional to capital A times dv upon dx. Okay, now what? When we remove this proportionality sign, then we have a constant eta, a dv over dx. So this is a constant which is called coefficient of viscosity. Coefficient of viscosity. So I hope that up to here it is clear now. Now question is, how we can say that f is directly proportional to dv over dx, or f is directly proportional to capital A, or we can area of the surface? It is quite simple. These two observations are quietly based on the experiments. There are several experiments performed, and after that this result comes in front of us. Okay, so this formula you have to learn by your heart, and I hope, I believe that this formula is quite easy to learn for all of you. Okay, now we will discuss about the unit. So SI unit of viscosity is Newton second meter inverse 2. And how it comes? As we know that we have a formula, that is F equal eta times A and dv over dx. Now we have to calculate, we have to find out the SI unit of eta. So we can simply write that eta is nothing but F and divided by A times dv over dx. Now put the units of each and every quantity. So force can be represented in Newton, area that will be in meter square, velocity that will be in meter per second, and divided by dx, that is also separation, or we can say the distance, that is in meter. So you can easily see that this meter and this meter will be cancelled out, and we get that it is the Newton second meter inverse 2. So I hope and I believe that this is clear to all of you. Okay, so this is your SI unit system, or we can say international system. So in SI unit, the unit of viscosity is Newton second meter inverse 2. Now if we convert that SI system into CGS system, then in place of Newton we have to write dyne, as we know. In place of second it will be second, in place of meter it will be centimeter. So the new unit, or we can say the unit in CGS system, will be dyne second centimeter inverse 2. Okay, that is correspondence to the SI unit. Now this unit means dyne second centimeter inverse 2, that is equal to poise. In short, it is written as poise. So we can simply say that poise is equal to dyne second centimeter inverse 2, or poise is the CGS unit of the viscosity. Okay. Now if we have to convert the CGS unit into SI unit, then we have a relation that 1 poise, and that is equal to 0.1 times Newton second meter inverse 2. So you have to learn what you have to learn. You have to learn what is the SI unit of viscosity, number one. Second, what is the CGS unit of viscosity. Third, what is the other name of CGS unit of viscosity, and what is the relation between CGS unit of viscosity and the SI unit of viscosity. So there are 4 questions in front of you, and I hope that it is clear. Now what? We will discuss about the dimensions of the coefficient of viscosity. Means we have to calculate the dimension also. So for that we will again write the formula of coefficient of viscosity, that is F upon A times delta V upon delta X. The same formula you can see here. By using this main formula we have converted, or we have derived the formula for eta, that is F over A times dV upon dx. So that is F upon A times dV upon dx, or delta V upon delta X. Now we have to calculate the dimension. So in front of force we can write m into A, because force is nothing but mass into acceleration. Area is your, we can say, the length square. Okay, so length into width or length square, whatever you can write, and speed, that is your distance upon time, and divided by x, also your distance. So it can be rearranged and can be written as m times A divided by L into B into L divided by T into L. So L to L cancelled out, and we can write here eta, that will be MA divided by your L into B, and T will be go upside. Okay, so the dimension of mass, that is capital M. The dimension of a acceleration, that will be LT to the power minus 2. The SI unit of time, that is capital T, and divided by length, that is also L, and width, that is also L. Okay, so it can be rearranged, and we can write that will be M L T to the power minus 3, sorry, minus 1, it will be minus 1. So we will rough it, and we will write that will be our minus 1, and divided by, this will be in capital bracket, and this will be L square. So eta will be m L to the power minus 1 T to the power minus 1. So this is your final dimension of the coefficient of viscosity. I hope and I believe that this thing is clear to all of you. Okay. Now in this lecture we will discuss about the flow through a narrow tube, and this is especially derived by the famous French scientist Poiseuille. So that's why this is also known as Poiseuille equations. Poiseuille observed by his experiment that due to viscosity, or we can say because of viscosity, the layers in contact with the walls of the tube remains at rest and the layers away from the wall move fast. What does it mean? It means let's suppose that we have a tube. So let's suppose this is your tube, or we can say the water tube, in which water is, or we can say fluid is flowing through. Okay, now we have a we can simply say that water here. So this is a layer, and this like this way, this is your layer. Okay, like this way. Now it is clear. Okay, this is your one layer, this is your another layer, this is your another layer of the fluids are there, this is your another layer, this is your another layer, like this way. So there are several layers of the fluid which is flowing through the tube. Okay, now if we see the layer which is close to the, or we can say in contact with the walls of the tube, means this one is layer and this is a layer which is in contact. So this is in contact with tube. Okay, so this is contact with tube, and the layers which are in contact with tubes will be at rest. So these layers are at rest basically. Now these layers which are in between move with velocity v. It means we can simply say that if we named as layer number 1, 2, 3, 4 and 5, then layer number 1 and 5 will be at rest. Layer number 2 and 4 move with velocity v1. Layer number 3 move with velocity v2. So v2 is greater than v1. This is the observations which is made by the Poiseuille. And on the behalf of this experiment, finally he proposed a calculation or a observations that what he found that the volume V of the fluid flowing per unit time t. It means if the volume which is flowing through the tube is capital V, and the rate of the flow means divided by t through the tube, that depends upon, depends means directly proportional to, that depends upon pressure gradient. So pressure gradient is P upon L. I have already told you that when you divide anything with the distance, then it converted into gradient. Let's suppose we have to write the force gradient, then it will be F upon L. We have to write the velocity gradient, then it will be V upon L. If we have to write the pressure gradient, then it will be P upon L. Okay, means if any physical quantity is divided by the distance, then it converted into its gradient. Okay, and also coefficient of viscosity means eta, and the radius of the tube, that is r. So V upon T, that is directly proportional to P upon L times eta times r. Now with the help of dimension we can easily derive the final expression for V upon T. So how we can calculate it? Let's get started. Firstly, this is your first quantity, so let the power be A. This is your second quantity, so let power B. Third quantity, let power C. And this is your equation number first. Okay. So V upon T, when we remove the proportional sign, then a constant K comes. So P over L, and the power raised by A, eta power raised by B, R power raised by C. So this be your equation number capital A, let's suppose. Okay, now with the help of dimension, we will put the dimension of each and every physical quantities. So as you can see that it is your V. V comes for the volume. So the dimension of volume, that is nothing but L cube, and divided by T. So dimension of T, that is capital T. K is your constant, so every constant is dimensionless. Now pressure. As we know that pressure is nothing but your force upon area, and the dimension of force, that will be M into small a, and this will be L square. So the dimension of pressure, that will be ml minus 1 T minus 2. Okay, so with the help of the dimension of pressure, we can directly write that m times L minus 1 T minus 2, and the power be A divided by L, so it will be L, and the power again be A into eta. So dimension of eta I have just shown to you. The power of eta, that is ml minus 1 T minus 1. So m L minus 1 T minus 1, and the power raised by B, and R is again the radius, or we can say in terms of dimension, it will be L, so power will be C. Okay, now what? We have to rearrange this. So what we have written is L to the power 3, and T is in divide, so power will be L to the power 3, T to the power minus 1. So L to the power 3 and T to the power minus 1, that will be one side of the expression, and the other side ml minus 1 T minus 2. So ml minus 1 T minus 2, and the power is your A divided by L, so, and the power will be A into ml minus 1 T minus 1, so ml minus 1 T minus 1, and the power will be B, and then L power be C, as you can see here. Okay, now what? Rearrange. So it will be L cube T to the power minus 1, that will be equal to m to the power A, L to the power, you can see that this is L to the power minus A, and this will be again minus A, so minus 2A. So L to the power minus 2A, and T to the power minus 2A. So this is your in first bracket. Here you can write m to the power B, L to the power minus B, T to the power minus B. This will be in second bracket, and in third bracket L to the power C. So it will be L to the power 3, T to the power minus 1, and this will be m to the power A. As you can see that this is m to the power A, this is m to the power B, so it will be A plus B. Okay, now come to the L. So L to the power minus 2A, it will be minus 2A. Here L to the power minus B, so it will be minus B. Here plus C, so it will be plus C. Now come to the T. So T to the power minus 2A, so it will be minus 2A. It will be minus B, so minus B. Okay, like this way. Now compare both sides. So if we compare, as you can see that this side there is no m, so we can write A plus B, that will be 0. Here L to the power this one, and here L to the power 3, so we can write minus 2A minus B plus C, and that will be equal to 3. Okay, now you can see that here t to the power minus 2a minus b, here minus 1, so minus 2a minus b, and that will be equal to minus 1. So we have three equations, and we have three unknowns also, a, b and c. So it is quite easy to solve the question, or we can say quite easy to solve the equations. So let's get started. We will solve and we will find the value of a, b and c by using the three equations what we have get here. Okay, so for that firstly we will write the three equations. First is your a plus b, that is equal 0. Second your minus 2a minus b plus c, minus 2a minus b plus c, and that is equal to 3. So this will be 3. And third equation minus 2a minus b equal minus 1. So minus 2a minus b, that is minus 1. So these are the three equations what we are going to solve. So you can easily see that from this equation you can write that a is nothing but that will be equal to minus times b. Okay, so in place of a you can write minus 2, that is a. So a will be minus b, so minus b, so this equation, and this will be minus 1. So that will be minus and minus, this will be plus. So 2b minus b, that will be minus 1. So it can be written as 2b minus b, it means b equal minus 1. So this is the value of b, and when we place the value of b here, then we get the value of a, that will be plus 1. Okay, so we have calculated the value of a and b. Now with the help of this equation, this is your equation number second, or we can say, okay, so here we can write minus 2 and the value of a, that is 1, minus b, so it will become plus 1, plus c, and that will be equal to 3. So it will be minus 2 plus 1 plus c, that is equal 3. It will be minus 1 plus c, that will be equal to 3. So the value of c what we get here, that is 4. So we have the values a, that is 1, b equal minus 1, c equal 4. So from equation number a, as you can see here, equation number a, b and c, put the values of each and every one. So we have the result as v upon t, that is equal to k times p over l power a, and we have eta b r c, eta b and r c, and we have calculated the value of a. The value of a is 1, b minus 1, so a is 1, b equal minus 1, and c equal 4. As you can see here, c equal 4. So we will put the value. So v upon t, that will equal to k times p upon l, and the power is 1. Eta, the power is minus 1, r power will be 4. So it can be written as v upon t, k times p over l into 1 upon eta into r to the power 4. Now by different experiment it is calculated that the power the value of k, that is pi by 8. Okay, so final result is v upon t equal pi by 8 p r to the power 4 upon eta times l. So this is the final result what we have calculated. We means Poiseuille have calculated for the rate of flow of fluid in any tube. Okay, so I hope and I believe that up to here each and everything is clear to all of you. Now what you have to do, you have to write these derivations in your fair copy. Okay, now try to derive each and every expression by yourself, and if you have any doubt then you can ask me. Okay, so thank you very much, thanks for listening me, thanks for watching me, thank you very much and best of luck.